Hello, hi everybody. Today we are going to learn about respiration in organisms for 7th standard children. We have heard the term respiration in organisms as organisms are plants, animals and microorganisms. And all these plants, animals and microorganisms, they are coming under the heading living things. What are living things? Living things have certain characteristics, certain important characteristics as living things need nutrition, as they take in food, and living things respire, living things excrete, living things move from place to place except plants, and living things reproduce. These are the common characteristics for living things. In that, one among that, what we are studying it as respiration in organisms. Actually, respiration is the physiological process. What is physiology? Physiology is nothing but the functioning of organ systems. In every living organism, the functioning of those organs and organ systems, they are coming under the heading physiology. And in that, we are going to learn about respiration. Now, this respiration, normally we say, when you are asked to climb up the stairs, at your age, you will just move. You can just climb up easily. A middle-aged person, say for 35 to 40 years of age, when that person is asked to climb up, they may be moving at little speed. They may be moving at little speed. If you are asking me to climb up, I will climb up, but after reaching that first midland place, I will breathe out little faster, isn't it? Because I need more energy, I need more oxygen to climb up the stairs. Like that, the movement of this body structure when you are climbing up, it needs energy. For that, we need oxygen. That taking in oxygen, it depends on the person to person. So that process is called respiration, and the rate of breathing is the breathing rate. It may be faster, it may be slower, it may be normal. It varies from person to person, and also it varies from different activities. For example, when a person is reading, he is at rest. So normal breathing rate, yes. When we eat faster, we need more energy. When we walk, when we are asked to run faster, say for example, in a games period, first year PT teacher will ask you to go for a round on the ground, is it not? So when we are coming round faster, we breathe faster. So different activities varies from person to person. Breathing rate is different from person to person, and also different activities to activities. That breathing process is respiration. Now this respiration, normally we again come across two terms. One is breathing, another one is cellular respiration. The act of taking in oxygen, giving out carbon dioxide is called breathing. That is respiration. Another term, cellular respiration, it is taking place inside the cell. What is a cell? Cell is the structural and functional unit of life. Now it is very much needed in a living organism. It is very much present in a living cell, and it arises from pre-existing cells, and also it repairs and remove the damaged tissues and gives energy. So inside the cell, when the glucose is broken down into simple substances and made into usable energy, that is cellular respiration. I repeat, cellular respiration is the breakdown of glucose into actually carbon dioxide and water plus energy, that is made into usable energy. So the food that we are taking, that food should be conserved as energy, and that energy should be burnt out into calories. Otherwise, if we keep sitting and without doing any work, that energy will be accumulated. That in turn we will become obese. Obese na அப்படியே குண்டாயி ஒரு வேலையும் செய்ய முடியாம அப்படியே மம்மா உட்கார்ந்துட்டு இருக்கோம். அது இல்லாம it has to be burnt out. The calories to be burnt. It has to be made into usable energy. So cellular respiration is the breakdown of glucose. Glucose again the food that we are taking into simple substances and made into usable energy. So that is cellular respiration taking place inside the cell. Cell is the functional and structural and functional unit of life. Next we are going to come about study about the structure of human lung. In human, the structure of human lung is as it is having the structure as starting from the nose. Starting from the nose, what we are seeing here, this is the external nostril, and inside that is the internal nostril, and that is called nasal cavity. See here, this is the nasal cavity. From here, this is internal nostril, nasal cavity, that is continued as pharynx. The thondai சொல்லுவோம்ல pharynx. The pharynx it has several openings. One from the mouth. The buccal cavity lende food போறது food pipe குள்ள போகும் esophagus-ல. அப்போ pharynx opening இருக்கும். And then ear ear lobe, ear drum குள்ள air போறது, that is also opening into the eustachian tube. அப்போ pharynx இருக்கும். The air from the nasal cavity when it is reaching, அப்போ pharynx opening இருக்கும். So now this pharynx is continued as larynx. Larynx na the epiglottis opening, the food pipe wind pipe separate பண்ற structure larynx. Then it is continued as trachea. Trachea, it is a cartilaginous bone. Cartilage, I will come to that next. Cartilaginous bone, it is tender and flexible, and that is continued into two branches, that is called bronchi. Trachea, flexible cartilaginous rings சொல்லுவோம், inverted C-shaped rings சொல்லுவோம், and that is branching into two, that is bronchi. Bronchus singular, bronchi plural. Then it is the entering into both the lungs. Here this right lung, it is formed of 3 lobes, and left lung, it is formed of 2 lobes. Lungs are nothing but a spongy structure, and that bronchioles in turn branching into main fine bubble-like structure called alveoli. These alveoli, they are nothing but blood capillaries for the exchange of gases. Then this lung, it is resting on a basement sheet, that is called diaphragm. Now the lungs, as it is present in the thoracic cavity or chest cavity, this diaphragm is separating the chest and the abdomen, or the thoracic cavity and the abdomen. This is forming the structure of lungs. So I say the nasal cavity as first external nas, internal nas, nasal cavity, pharynx, larynx, trachea, bronchus, intern bronchi branching into bronchioles, alveoli, diaphragm. This is forming the structure of lungs. Now when we talk about mechanism of breathing, இது எப்படி ஏர் உள்ளே போகிறது வெளியில் போகிறது, அதுக்கு வந்து two important events taking place. Now what we are seeing, these lines are the rib cage. We know that there are 12 pairs of ribs. Now this rib cage, we name it as a thoracic cavity, otherwise the chest region. So now this mechanism, it has two processes. One is breathing in, another one breathing out. Otherwise we say inhalation and exhalation. Otherwise we say inspiration and expiration. Now there are two important events taking place in inspiration or inhalation as diaphragm contracts. Another one, chest expands. When air enters in, the diaphragm contracts, forming a flat structure. அப்போ chest வந்து expand ஆயிரும். அப்போ volume of the chest cavity will be more. அப்போ air pressure will be less. அப்போ oxygen when it pushed in, more pressure pushing into the chest cavity, and then oxygen enters. It will be entering till it equalizes the pressure. That is inspiration. The chest expand வந்து நான் இன்னும் ஒன்று அப்புறமா சொல்கிறேன். chest cavity expand ஆகிறது வால்யூம் ஜாஸ்தி ஆகும். diaphragm contract பண்ணி chest expand ஆகிறது வால்யூம் ஜாஸ்தி ஆகிறது. அப்போ ஏர் புஷ் ஆகி it equalizes the pressure, oxygen enters. This process is inspiration. Whereas expiration அப்படியே உல்டா, otherwise போயிடும். diaphragm relaxes, chest cavity contracts. அப்போ more pressure உள்ளே இருக்கிறது அது வெளியே தள்ளிடும். Carbon dioxide will be sent out. This is breathing out. This is a procedure for mechanism of breathing movement. Now here, super. Mechanism of breathing, it is as inhalation, otherwise called inspiration. Inhalation or inspiration or breathing in as first nasal cavity air enter agum, it reaches the pharynx, then trachea, then it comes to bronchi, bronchioles, alveoli, and then reaching the capillaries. Capillaries are nothing but blood capillaries as arterioles and venules. So the arterioles will give the oxygen to the alveoli, exchange with the venules for carbon dioxide. That is inspiration. Whereas expiration is a reverse. Capillaries இருந்து venules carbon dioxide alveoli க்கு வந்து அங்கிருந்து bronchioles, bronchi, trachea, pharynx, nasal cavity. The trachea வந்து இப்படி போடுறோம்னு சொன்னாங்க, இது வந்து flexible structure, cartilage. We come across the term cartilage. In human skeleton, normally bones சொல்றோம். And the bonesல it has slightly flexible bone. எல்லா போனும் flexible ஆகாது. Only the nasal bone and the ear bone and cartilage will have a flexibility. And this cartilage trachea is having inverted C-shaped structure. So that is for the mechanism of breathing. So here exhalation, as I said, reverse. Again then, capillaries, alveoli, bronchioles, bronchi, trachea, pharynx, and nasal cavity. Like a chinna I say, what I am holding is the thoracic cavity. This is the diaphragm. Diaphragm. This is the chest portion, chest cavity or thoracic cavity. This is the abdomen. Now this abdomen, diaphragm is separating the abdomen and the chest. Now what I am holding is the chest cavity. Now this is the trachea. Now what we are seeing, yellow color is the two lungs. So when you blow, it will blow. It comes towards the structure. See here. Can you see? The air enters in. So the balloon is inflated. Balloon movie period, that is balloon inflates as air enters. Air entering is nothing but oxygen entering into that. This is a improvised apparatus to show the mechanism of breathing. Then come to next point, aerobic and anaerobic respiration. Now the respiration that is taking place in presence of oxygen, that is called aerobic respiration. Respiration that occurs in presence of oxygen, that is called respiration. 1 minute. C6H12O6 plus 6O2. That will give 6 CO2 plus 6 water plus 2900 kilojoules of energy. This is the equation for aerobic respiration. As this is glucose, this is oxygen. So in presence of oxygen, it is giving carbon dioxide is evolved, water is formed, and 2009 kilojoules of energy will be released. That is aerobic respiration. This kilojoule is the measurement, unit of measurement for energy. Now, cellular respiration. And glucose in presence of oxygen broken into carbon dioxide and water made into usable energy. That is aerobic respiration. When we say this one, you should recollect another point, as we have studied nutrition in plants. Bottom side on the nutrition in plants. What is the process? It is photosynthesis. Photosynthesis is the preparation of food by the green plants. What are the raw materials? Carbon dioxide and water. In the reverse. Carbon dioxide and water in presence of sunlight and chlorophyll, it will be forming glucose, and oxygen will be evolved as a byproduct. So here I say photosynthesis, it is a constructive process, and respiration is a destructive process. But in photosynthesis, food is stored in, and in respiration, the prepared food is made into usable energy. So this is called the anaerobic respiration. Then in anaerobic respiration, we have first one, anaerobe in the absence of oxygen. Anaerobic respiration in the absence of oxygen. Now, microorganism, lactobacillus changing milk into curd. That process is fermentation. With the help of another experiment, preparation of alcohol, wine and wine with the help of yeast. That is making in formation of alcohol, wine and wine in presence of yeast. That is anaerobic respiration. So the organism lactobacillus and yeast, they are called anaerobes, and the process is called anaerobic respiration. And this another one is, say for example, it is taking place in the absence of oxygen. So what happens? Glucose, in the absence of oxygen, carbon dioxide and water from energy will be there. Instead it is forming ethyl alcohol will be forming. Carbon dioxide and ethyl alcohol will be forming, and the energy will be very little. 50 kilojoules of energy will be forming. So So now another one, this anaerobic respiration, this is a formation of ethyl alcohol. Another one, glucose, in the absence of oxygen, it is forming lactic acid. Lactic acid formation is also type of anaerobic respiration. Here it is mainly taking place in the muscles. Muscle cell. Normally, sometimes cramp formation ஆகுது சொல்லுவோம்ல, தூங்குறோம் இல்ல கை மரத்து போறது, தூங்குறது நம்ம தெரியாம காலை ஸ்ட்ரெச் பண்ணிட்டோம்னா காலை இழுத்துக்கிறது சொல்லுவோம்ல, that is a type of anaerobic respiration. When there is deficient supply of oxygen, that making the formation of cramp. So here formation of lactic acid. So muscle cramp is the anaerobic respiration where lactic acid is formed. Even the fast running athletes, avalukku cramp pidichukonde, avalukku formation of lactic acid. Ana idella temporary, permanent ah kedaiyadhu. Apparama supply oxygen more ஆனது இது வந்து சரியாயிடும். I hope you are able to follow this. So here anaerobic and anaerobic we are studying about the respiration. So what I explained so far is about the structure of human lungs and then mechanism of breathing and the aerobic and anaerobic respiration. What is the equation for aerobic respiration? C6H12O6 plus 6O2 will give 6CO2 plus 6H2O plus 2900 kilojoules of energy. That equation is meant for presence of oxygen. Whereas in the absence of oxygen, we have two types of end products. One is ethyl alcohol formation, another one is lactic acid formation. Normally ethyl alcohol formation we talk about fermentation, whereas lactic acid type of lactic acid product lactic acid formation is for temporary deficient supply of oxygen in the muscles. Typical example for lactic acid formation is formation of muscle cramps. And then when the athletes are running faster, their breathing rate will be higher and they may get a chance for formation of muscle cramp. Next we are talking about respiration in lower animals. As first one, amoeba, it is by simple diffusion. Diffusion it is a physical process where there is just exchange of gases. That is simple diffusion and it is done through the body surface. Another one is again simple diffusion in earthworm. It is through the moist skin. Throughout the segments of the earthworm, நிறைய pores are there through the moist skin. Exchange of gases taking place. The next one is cockroach. It is having a tracheal system. Higher animals mari well formed lungs lam kedaiyadhu. It is having a tracheal system and both the sides of the abdomen the tracheal tube will run, and then when the exchange of gases occur, that is done through a opening that is called spiracles. These spiracles will take in oxygen and giving out carbon dioxide. So tracheally type of respiration with the help of spiracles taking place in the cockroach. Next one is fish. Is by the gills. Fish is an aquatic form as we all know. So respiration is taken through the dissolved oxygen is taken through the gills. Next one, frog. First I'll talk about tadpole. Tadpole is a larval form of frog. So it is with the help of gills. Larval form tadpole is aquatic. So respiration is through the gills. When it comes to the land habitat, it is a moist skin. Skin வந்து எப்பவுமே ஒரு மாதிரி வெட்டா that moist skin, it is called cutaneous respiration. and then lungs will be present, that is pulmonary respiration. Sometimes this frog will open its mouth. That mouth will also capable of respiring, that is buccal respiration. So in frog we come across tadpole, gill respiration, adult terrestrial habitat, adult frog will respire through skin, cutaneous respiration, lung, pulmonary respiration, and mouth, buccal respiration. And the same respiration, it is taking place in plants also. That is, again, in plants, respiration, it is through the stomata, a structure called stomata. Now, the stomata, normally, it is green in color, having two bean-shaped or kidney-shaped cell called God cell, and having chloroplast and other nutrient, and it is like this, and it is surrounded by the epidermal cells. Now this is the outer epidermal area where the stomata will be present. This is the God cell. This is the epidermis of the leaf. Now this God cell, by opening, this is the opening. By opening and closing of this stomata, exchange of gases taking place. Exchange of gases are again taking in oxygen, giving out carbon dioxide. But in plant, we have as photosynthesis and respiration. There, photosynthesis, what happens? In photosynthesis, as carbon dioxide is taken in, oxygen is given out. Whereas in respiration, oxygen is taken in and carbon dioxide will be given out. In plants again, this oxygen evolved during photosynthesis that can also be utilized by the green plants for its respiration. That is called photorespiration. Photo means light. In presence of light, when it is taking place, it is called photorespiration. Other than that, full throughout 24 hours, the green plant will respire. That is usually termed as dark respiration. So this is the respiration in plants. Again, the root also respire along with the root hairs. Every part of the body, plant body, will have the process of respiration. But we mainly talk about with the structure of stomata. Opening and closing of stomata, exchange of gases will occur. That is what respiration in plants. I hope you have understood. Recollect all the points what you have learned now. We'll meet in the next class. Thank you.